All right, today we're going to dive deep into something that sounds simple but is, well, pretty much everything. We're talking about the most fundamental job any processor has, the art of just moving data around. I mean, you ever stop and think about that? How does your phone run a dozen apps at once without completely scrambling their data? How does your music app find its playlist while your map is navigating and they don't, just crash into each other? Well, it all comes down to one thing: control. Really, really precise and efficient control over moving information from point A to point B. That is the secret sauce. So, let's get into it. Okay, to really get this, let's think of the processor as a workshop. You've got your registers. That's your workbench. It's super fast. It's right there in front of you, and it's where you do all the real work. The only problem? It's tiny. You can't fit much on it. Then you've got memory. Think of that as this enormous warehouse out back. It holds everything you could possibly need, but man, it's slow to go fetch stuff. So the entire game, really, is just about efficiently moving things between that giant warehouse and your little workbench. So, what are the most basic tools in this workshop? Well, that would be LDR and STR. It's basically a simple two-way street. LDR, which stands for load, is you walking over to the memory warehouse, grabbing a piece of data, and bringing it back to your register workbench. An STR, or store, is just the opposite. You've finished working on something on your bench, and now you're putting it back in the warehouse to store it safely. And what's so cool is that the syntax itself actually shows you which way the data is going. Look at this. For LDR, the arrow points into the register. You're loading into it. For STR, the arrow points out of the register, heading to memory. It's this simple, really elegant visual cue that's baked right into the language. All right, so moving one thing at a time is fine. It works, but it's not always the most efficient way, right? We want to work smarter, not harder. And that's where we get into some really clever ways of addressing memory. Now, don't let these names on the screen throw you. All they are three slightly different, clever ways to grab stuff from our warehouse. The only thing you really need to pay attention to is when our map, the base register, gets updated. Does it happen before we grab the item, after we grab it, or, does it not get updated at all? Let's walk through an example to make this super clear. Let's say our base register, R1, is our map, and it's pointing to address 0x9000 in our warehouse. But the item we actually want isn't right there. It's 4 spots down the shelf. Okay, so check out this instruction. See that exclamation point at the end? That little guy is the key to the whole thing. It's called write back. So here's the sequence of events. First, the processor calculates the target address. It takes our base, R1, and adds the offset, 4. Simple enough. Second, it goes to that new address and loads the data into our register, R0. And then, this is the magic part, it updates the R1 register with that new address, all in one go. So what just happened? Think about it. In a single instruction, we didn't just grab the data we needed. We also moved our pointer forward automatically. It's now perfectly lined up, ready to grab the very next item in the array. That is just incredibly efficient. And why do you care? Well, if you've ever had to loop through an array, this is the secret sauce. It lets you step through data, one piece at a time, without having to write a separate line of code just to increment your counter. You're letting the hardware do that boring bookkeeping for you, which makes your code cleaner and faster. Okay, so moving individual boxes is great, but what if you need to move a whole pallet of boxes? That's when you bring out the heavy machinery. We're talking load and store multiple. I mean, just look at the before and after here. It's wild. Before, you have a pointer and 3 empty registers. Then, bam! One single instruction later, all 3 registers are filled with data straight from memory. And look, the pointer has already moved to the end, ready for the next block. And the command that does all that, it's LDMI. If LDR was you carrying one box, this is the processor's forklift. It's basically saying, hey, starting at this address, grab a whole bunch of stuff, load it into registers R1, R2, and R3, and yeah, move the pointer for me when you're done. It's an absolute powerhouse for moving data in bulk. And you use this forklift for all the big jobs, right? Need to copy a massive block of memory? Forklift. What about saving the entire state of your program, like everything on your workbench, so another task can run for a second? That's called a context switch. And yeah, you use a forklift for that too. It's fundamental to how modern multitasking even works. All right,
So every good workshop needs more than just hammers and forklifts. You need those really precise, specialized tools for critical jobs. In the ARM world, one of the coolest is the atomic swap.
And the keyword there is atomic. In this context, atomic means it's an all-or-nothing deal. It's completely uninterruptible. Once a swap operation starts, the entire system basically freezes and lets it finish. Nothing else can interfere with that specific piece of memory. It's a total lockdown. So how does it work? It's like a perfectly choreographed dance. In one single unbreakable move, it first reads the value that's in memory and secretly stashes it away. Then it writes the new value from your register into that memory spot. And finally, it takes that old value it stashed and puts it back into your register. It's this beautiful, seamless exchange. Yeah, this quote really nails it. The system holds the bus. The bus is like the main data highway in your computer. And the swap instruction basically puts up roadblocks until its transaction is done. And this is crucial for preventing something called a race condition. That's when two different programs try to change the same piece of data at the exact same time, which, as you can imagine, leads to total chaos. So let's recap our processor's toolbox. You've got your basic hand tools, LDR and STR, for moving single items. You've got your smart techniques, the addressing modes, for doing precision work efficiently. You've got your heavy machinery, LDM and STM, the forklift for moving stuff in bulk. And finally, you've got that specialist tool, the swap, for those critical jobs that absolutely, positively cannot be interrupted. And at the end of the day, everything, and I mean everything your computer does, from a simple calculator app to a massive, complex video game, it's all built on these simple moves. These are the fundamental verbs of computation. And once you really understand the tools, it starts to make you think, what could you build?